with a BS in biology, along with minors in chemistry and piano performance. Quite remarkable. Prior to beginning dental school, he completed a summer internship in the Mary Bob Randolph Cancer Center undergraduate research program under Dr. Linda Von Davis. He's a third-year dental student, first time we've had an undergraduate dental student present here, and continues to work in Dr. Linda Von Davis's lab. The work that he will be presenting was selected for presentation at the 100th American Association of Cancer Research annual meeting in Denver, Colorado last year. The title of the paper is Leptin Stimulates Growth, Cell Motility, and Invasion in Head and Neck Cancer. The lead author is our...
So my name is Dustin Getz. I'm a third-year dental student here, and what I want to talk about today is a link we found in a study between obesity and oral cancer. I want to mention I first became interested in this when I was doing a couple internships in the cancer center. In the first summer I studied a similar project dealing with leptin, but we looked at prostate cancer. And I came back to the second study having been accepted to dental school, and prostate cancer just didn't make any sense anymore. So we switched gears to something a little more applicable to dentistry and looked at oral cancer. So the link we're talking about here is a hormone called leptin. Leptin is produced in adipose tissue or fat cells. And it's expressed by the OB gene, the obesity gene, inside the adipose tissue. And under normal circumstances, it serves to regulate body weight. This leptin produced in the fat will circulate the blood and bind to receptors in the hypothalamus of the brain and tell us that we've had enough to eat. We don't need to eat anymore, we have plenty of energy. And you can see the way this works. It's produced in the fat, up to the hypothalamus, and then it tells us we're full and we don't need that extra colon, esophagus, among others. And then also in 2003, McFadden and others demonstrated a metastatic potential due to leptin in esophageal squamous cell carcinoma. However, in this growing body of evidence supporting leptin in this way, no one has taken a serious look and evaluated how leptin affects the oral squamous cell carcinoma. This being one of the most common oral cancers, could be efficacious to take a look at this. So based on that evidence I was telling you about, we formulated a hypothesis that leptin may have some biological effects in stimulating the progression of the oral squamous cell carcinoma, particularly in three areas. And these were increased cell proliferation, increased cell motility, and increased cell invasion. So we started by obtaining some oral squamous cells that help it move. So we can think of cortactin as a sort of movement protein. We'll come back to that shortly. I just wanted to introduce it to you. So as I said, we evaluated these cells for their proliferation, motility, and invasion in response to leptin. So we started with the proliferation assay. Here we're measuring cell growth. The way we assessed the cell growth was by measuring mitochondrial respiration. If the cell's carrying out mitochondrial respiration, it's alive and it's viable. So we plated some cells and we treated them with leptin or without leptin. We incubated them for a couple days. Then we treated them with this MTT reagent. As I said, if the cell's carrying out mitochondrial respiration, it's alive and it's producing a certain enzyme that can break apart this chemical and leave behind a purple color. So then the more cells we have, the deeper and darker this purple color. And we can quantify this by reading the optical density, and then we can compare our treatment groups. And what we found here was a statistically significant dose-dependent increase in cell proliferation. We can see it is most dense right around the nucleus of the cell. Didn't really know where to expect the cortactin to be in these cells, so this was fine. We wanted to see what happens when we add the leptin. If you look at the picture on the right, you can see the actin still around the nuclei of the cell. It hasn't changed. But the cortactin now has shot out to the periphery of these cells. No longer is it clustered right around the nucleus. It's evenly distributed throughout. So these cells are better equipped to move because their movement protein is out at the periphery of the cell where it can carry out its action. So if we boil all this down, we can come up with a few conclusions here. We see that leptin stimulates the proliferation, the motility, and the invasion of these oral squamous cell carcinomas. And we think the mechanism may involve the relocalization of cortactin from the perinuclear space, right around the nucleus of these cells, out to the periphery of the cell, where it's in a better position to carry out its action and help the cell move.